In this Excel file, I have done something similar to the previous section's Excel file, although I first calculate the mean of just the first 5 die rolls. So I calculate the mean in this pink row, and that's just using a sample size of 5. But then I come down here and I say, all right, take those 5 and then calculate the mean of those 5 plus all the way down to the 50 rolls. So as if we rolled the die 50 times and then calculated the mean. And then I do the same thing all the way down to 200. So we've got a mean for a sample size 5, for a sample size 50, and a sample size 200. And I just want to see what happens with the distribution of those means as the sample size grows. So with this section, what should happen is that as our sample size grows, we should become more normal. And then, as promised in the previous Excel file video, we're going to look at the variance, and hopefully, because the variance when the sample size was 5 did not look very normal, so hopefully with a larger sample size, our variance will look bigger. So let's first of all look at how these samples, the sample means, are distributed when the sample size was just 5. So as if we only rolled the die 5 times each of these on each of these samples. So if our sample size is 5, this looks about like it did in the previous Excel file. You know, it looks somewhat normal, low on the ends, high in the middle, but not exactly normal. So if I look at where the sample size is 50, so I rolled the die 50 times, it's looking maybe a little more normal, maybe not. But then if I increase the sample size to 200, well, now this looks very normal. So it starts low, gets bigger, and then drops off again, and is roughly symmetrical. So let's repeat these experiments several times. So let me come here and I'll say if I redo the entire experiment, so I roll the die 5 times and get the mean, do it again and again and again, come up with something similar, but again, the one that's most normal is the one with the sample size at 200. So if I do that over and over again, you'll see most of the times that I do this over and over again, we're getting something that's somewhat normal. So let's look at the variance now. We saw in the previous Excel file that the variance, when the sample size was 5, the variance of those die rolls was not very normal, even though we said variance should be approximately normal. But the issue was the sample size, because if I then increase the sample size to 200, then the way that variance is distributed is clearly much more normal. And I can repeat this over and over again. And I get a sample variance that is normally distributed pretty much every time.